Hey guys, welcome back to the channel. This is your physics buddy. If you are studying for your 2026 exam, you have come to a right place. Here you will find a detailed review of each and every topic you need to know, starting from electric charges and its properties. You know, no one has ever covered the complete syllabus of AP Physics 2 on YouTube, but I am going to be the one who covers the entire syllabus in upcoming video lectures, so make sure you hit the subscribe button and stay tuned.
We need to understand that what alpha particle is. So whenever we are talking about alpha particle, this thing comes to your mind that alpha particle is nothing but we call it doubly charged helium ion. So doubly charged helium ion means He plus, and when we're talking about the double of this helium ion, so the helium ion has one proton that is represented by E plus. So doubly means twice of proton. So we already know that the charge of proton is nothing but 1.6 times 10 to the power minus 90. And we have to find the charge of alpha particle. We simply multiply it with it with 2. So we are supposed to get 3.2 times 10 to the power minus 19. So again, don't remember the charge. Remember what alpha particle is, because this is very important, and we are going to deal with alpha particle once again when we are talking about modern physics. Because in modern physics, we were talking about Rutherford alpha particle scattering experiment. In that experiment, Rutherford chose alpha particles. So in order to see that how alpha particle is responsible for giving us the atomic model, we should understand that what alpha particle is exactly. All right, so it was a pretty simple question. Let's move ahead. So the next question that we should ask that if there is any charge that is being transferred, so is it possible that charge is transferred without the transfer of mass? Just think of it once. Whatever type
Yes,
of charge is being transferred, like proton or electron, they do have certain mass. Proton has certain mass as well as electron has certain mass. So we should keep this point in mind that whenever we are talking about proton, the charge mass of proton is nothing but 1.6 times 10 to the power minus 24 kg. Similarly, when we are talking about mass of electrons, so we'll say it is 9.1 times 10 to the power minus 31. So if there is any sort of charge transfer, so we can say that there must be some transfer of mass also. So the answer of this question is going to be yes. If there is a charge transfer, it cannot take place without transfer of mass. So not no, we should say yes. Not yes, we should say no, because charge cannot transfer without the transfer of mass. So whenever a body gains some charge, there must be some mass the body has acquired. Or if the body has lose some charge, it must lose some mass. This is what it should come to our mind. Similarly, there is another question. The question says one metallic sphere A is given a positive charge, whereas another identical metallic sphere B of exactly same mass as of A is given equal amount of negative charge. Then what we can say about the mass of A and B? Now just think of about it, that how we can say. So if a sphere A gets some charge, and that too positive, so it must have gained some protons, I can say. Similarly, if sphere B gets some negative charge, so we can say it must gain some electrons. So in both the cases, mass of both the spheres will increase. So we can say mass of A and mass of B, they both will increase. So the answer of this question is going to be B and D both are correct. That is what we need to understand here. Let's move ahead. Now this is one such important question. The question says how many electrons are required to create a charge of 1 coulomb. So it is very simple, like how we can actually understand it. So we have given here that the total charge we need to create or we need to have is 1 coulomb. Also, we know that the charge of one electron is nothing but 1.6 into 10 to the power minus 19 coulombs. So the question is how many electrons are required to make 1 coulomb of charge. So we can simply say that the total charge must be equals to number of electrons into charge of each electron. So number of electron can be calculated by simply dividing the total charge by charge of one electron, which is supposed to be E minus. So it is going to be 1 over 1.6 times 10 to the power minus 19. So here I can say that the number of electrons that are needed to make 1 coulomb of charge, it is going to be 10 over 16 times 10 to the power positive 19, and it is going to be 5 by 8, or you can say n is going to be 0.625 times 10 to the power 19, or I can say that it requires 6.25 times 10 to the power 18 number of electrons to constitute 1 coulomb of charge. So what you can infer from this particular result, you can infer that 1 coulomb of charge is not a small quantity, it's a huge quantity. So in order to have 1 coulomb of charge to be transferred, we need that much number of electrons, which is huge. You can see it's positive 18, 10 to the power positive 18. It means total number of electrons are going to be huge in number. So this is again an important result, or you can also remember the result, because sometimes we are going to use the result as it is in some of the questions when we are solving some questions. Let's move ahead. So the question, again, a new question. How many electrons are required to create a mass of 1 gram? So here we have given the mass as 1 gram. So always whenever we are solving any question here in physics, we have to solve in SI units, and the mass has SI units as kg. So 1 gram can be written as 0.001 kg, or I can say it is going to be 10 to the power minus 3 kg. So we have to answer that how many electrons will make this much of mass. So in order to answer this, we need to know the mass of one electron, and we know that the mass of one electron is nothing but 9.1 times 10 to the power minus 31 kg. Again, unitary method. If mass of one electron is this, so I can say n number of electrons must have mass 10 to the power minus 3 kgs. So how we can get it? So n times mass of one electron, which is going to be 10 to the power minus 3. So here n can be written as 10 to the power minus 3 divided by mass of one electron, which is going to be 9.1 times 10 to the power minus 31. So when we solve it, we'll get 1 over 9.1 times 10 to the power minus 3 plus 31. If we try to solve it, we'll get somewhat around 0.1 times 10 to the power 28. So almost 10 to the power 28 electrons will constitute the mass of 1 gram. Again, not a small quantity, it's a huge quantity. This much number of electrons are required to make 1 gram of mass. So again, an important result, and you should understand that how we are actually getting these results. Let's move ahead. So this is one such important question. Again, so question says if 1010 electrons are required by the body every second, then the time required for the body to get a total charge of 1 coulomb will be. Now, these questions are somewhat, you can say, based on unitary method. We are actually applying a unitary method to answer such kind of questions. So if every second 1010 electrons are being acquired by a body, so we can say that every second there must be some amount of charge which is being acquired by the body. So let us try to calculate that how much charge the body will acquire every second. So how we are supposed to find it? So we'll simply say that in 1 second, total of 1010 electrons are acquired. So we can say every second 1010 times what is the charge of electron? 1.6 times 10 to the power minus 19 coulombs. So we'll say every second this much amount of charge is being acquired. So we have to find out that in how much time, in how much seconds the body will acquire 1 coulomb of charge. So this is a pretty simple question. You can apply the unitary method. I'll be considering that it requires x seconds. So we'll divide both the equations and we'll get the value of x. Again, a unitary method, or you can say it's a ratios which you use to solve such questions. Always think analytically instead of thinking from the formula perspective. We are not supposed to apply any formula sometimes. We are just need to use common sense to answer the question. It's quite similar to answering a question which says if one pen is of 10 rupees, or you can say $1, so how many dollars will let us buy 100 pens? So it will be very easy. 100 dollars is required to buy 100 pens. So this is how you are supposed to answer these questions. So it is going to be 1010 times 1.6 times 10 to the power minus 19. So if you solve it, it is going to be around 10 to the power 19 divided by this particular number. You need to be a little more accurate with maths here. Calculation should be very accurate in order to answer all these questions. So it is going to be 1616. So if you divide the whole number by 1, we are supposed to get 0.006. One more zero is there. 0.00061 into 10 to the power 19. Now just simplify this number and try to answer or try to match the question options. So here I can say it is going to be around 6.1 times 10 to the power 15 seconds. Now this much number of seconds will constitute a charge of 1 coulomb as per the question. So again, you need to convert the seconds into hours, into days, into years if it is required. So how we are supposed to convert it? Let's see it. Let's simply convert 1 year into seconds and we'll divide the same and we're supposed to get the total number of years, that how many years will require. So I know that 1 year has 365 days. Similarly, every day has 24 hours. So 365 multiplied by 24. So this will give us hours. Similarly, every hour has 60 minutes. So we'll multiply the same by 60. So we'll get the whole in minutes. And again, if you have to convert it into seconds, so we can say it is going to be 24 into 60 into 60. So this will ultimately give us the result in seconds. So 1 year is equals to around this much seconds. Let us solve this. So 365 times 24 times 60 times 60. And it is going to be around 3153600 seconds. So not a small number again. So if you try to convert, if you try to solve it, so you can see it is going to be 6.1, it is going to be 3.1. So I can write it is 3.15 times 6 seconds. And it is almost around 15. So approximately, if I just divide these two numbers, we are supposed to get almost 20 years. So it will take almost around 20 years to convert, or you can say to transfer 1 coulomb of charge if 1100 are electrons are acquired by a body every second. So this is how you can actually relate the answers. Does this make sense?
Yeah, kind of.
If there is anything you want to ask, you can ask.
Okay.
Yeah. Whenever you feels like that you didn't get anything, just ask. Don't keep it in mind. We are here to discuss and we want to discuss. Let's move to the next topic. So basically, in the last class also we need to talk about this. This is the property of charges. Next thing we have to discuss that what are the properties of charges. The first property is that charges is additive in nature. What does it mean? So we need to understand here this fact that charge is nothing but a scalar physical quantity. So all those quantities which are scalar in nature, we can simply add them. Like for example, suppose there is a body and this body has different type of charges like 10 electrons, 20 electrons, 30 electrons, 40 electrons. So the total charge this body will have is because of the sum of all the electrons, which is supposed to be 100 electrons. So charge of 100 electrons will ultimately give us the charge of the whole body. How we can say this? Because charge is additive in nature. It is scalar quantity, so we can directly add it. The second property about charge is that charge is conserved. Conserved means charge can neither be created nor be destroyed. So whatever charge is being there, it can only be transferred from one object to another object. So that is the most important part about conservation principle. So we'll simply say that charges can never be created nor be destroyed. It can only transfer. So that is what we need to keep in our mind. Another property of charge is that charge is quantized. Now, this is the term which you might have heard in the class also. So, quantized means that whenever we are talking about that anything, any particular quantity is quantized, it means that that quantity is nothing but it is an integral multiple. It is an integral multiple of one such number. So, here we can say charge is an integral multiple of charge of electron. For example, like suppose there is a body and we have to find the total charge of the body. So what we were supposed to do is we can simply multiply that whatever number of charges or whatever number of electrons are present in the body with the charge of one electron. So this will give us Q is nothing but, or you can say the total charge of the body is nothing but product of N and E, where N is number of electrons that this body might possess, whereas E is something which we use to represent charge of electron. So these are the most important properties about charges, and we need to have its understanding. And this is something which we have already applied in previous questions. That is the quantization principle. So again, that is something you need to keep in your mind. Let's move ahead. So I already explained quantization means charge is nothing but product of number of electrons time total number of electrons times charge of single electron. So there is one question. Now just think about it and tell me which of the following given charge are not possible to exist. What can you think about it? Always remember the smallest charge that ever exists is charge of electron, and which is supposed to be 1.6 times 10 to the power minus 19. So any charge less than this will not exist. So just look at the question, look at the options and tell me which number is less than this number. Think about it. It's an easy one.
B.
Correct. So this is something which will not exist. Otherwise, every other number in terms of charge will exist. Now, this is the question which is supposed to be a homework. You can try this out. This is the quite simple one which we just discussed in the previous slides. The question is simply saying that the glass rod is rubbed with a silk cloth. The glass rod acquires a charge of this much number of coulombs. So the question is, how many number of electrons that glass rod must have lost? So you can try this out. I'll ask about this question in the next class. So we discussed about the properties of charges. Charge is conserved. Now just think of this question and tell me, mark out the wrong option. Which option is going to be wrong? The total number of charged particles in the universe is constant. And this is something you can relate as mass of the universe is constant. Because mass is something which we can relate with the charge. Every mass possesses some charge. If there is a mass charge transfer, there is a mass transfer. So mass can neither be created nor be destroyed. That is why we have that principle, conservation of charge principle is there with us. Because we are not actually talking about conservation of charge, we are actually talking about conservation of mass. Because mass and charge, they both are interrelated quantity. Always remember, in physics, we have learned only three conservation principles. The first conservation principle is conservation of mass. Second conservation principle, which you have already learned, it is supposed to be conservation of energy. And the third conservation principle is conservation of charge. Apart from these three things, there is no conservation principle that we follow, neither in physics nor in chemistry. Why? Because these three physical quantities are actually interrelated. Mass is interrelated with energy by the Einstein's famous relation E is equals to mc square. So here energy and mass are interrelated. Similarly, mass is also related to the charge by whatever we have learned so far in this unit. So always remember these points. So now there are few things which are possible. The first thing is charge can be at rest. Second thing is charge can be moving with a constant velocity. And the third thing is charge might be moving with some acceleration. So in all the three physical aspects, what we observe here is the charge behave differently or it actually affects the surrounding differently. So whenever charge is at rest, it is capable of producing electric field. This is the most important thing about it. And in this unit, we are actually going to discuss all the key factors when charges are at rest. And this is the unit which is supposed to be known as electrostatics. Similarly, when charge is supposed to be moving with a constant velocity, it can produce both electric field as well as magnetic field. And this is something which we are going to talk about later on in this particular section called magnetism. Similarly, if charges are moving with some acceleration, they produces some special type of waves which are known as electromagnetic waves. So these electromagnetic waves we are going to learn in the upcoming part of this particular grade as well. There are so many electromagnetic waves, like for example, alpha rays, beta rays, gamma rays, UV rays. Similarly, there are some X-rays, infrared rays, radio waves. So they all are the part of electromagnetic spectrum. So we are also going to talk about that electromagnetic spectrum in upcoming classes. So what we need to understand here is that how these things are produced. All these things are produced because of the charge motion. If charges are at rest, they will produce electric field. If they're moving with constant velocity, they're going to produce electric field as well as magnetic field. And if they are moving with some acceleration, acceleration means what? You can see here, this charged particle is actually moving with increasing speed. Where this charged particle in the second case is moving with a constant speed, its velocity is constant. But in the third case, its speed is increasing continuously. So that is something we call accelerated motion. So these are the following things that we actually going to learn in the upcoming sessions. Now, this is something which we already know. If the charges are of unlike nature, they are going to attract. So if they are going to attract, there must be some force that is going to be act between the positive and the negative charge. And that is the force which is called electrostatic force. Similarly, if charges are like in nature, so they are going to repel each other. Again, the force with which they are going to repel, it is known as electrostatic force. So next, we are going to learn about electrostatic forces, and this electrostatic force is something which is given by Coulomb's law. Again, here I would like to highlight one thing. There is the difference between laws and laws and theorems. In physics, we're going to talk about two such things. Sometimes we're going to talk about laws, sometimes we are going to talk about theorems. Now, what is the difference between laws and theorems? So, laws are those physical, you can say, effects that we observe in our surroundings, which has no explanation. Like we don't understand that why this negative repel, why this positive negative attract. But we will figure it out that what are the factors with which this electrostatic force can be calculated. So we just figure it out and we call it law. Whereas in theorems, we have a proper reason. So whenever we have a proper reason, in physics, we call it theorem. And whenever we are just talking about, you can say that these are the factors, and on these factors, this particular thing is going to depend upon, or this is something which is proportional to it. So that is something which comes under the law. So here in physics, you have learned so many laws. It all started with Newton's laws of motion. The Newton's laws, again, we just told that this is something which happens. Why is it happening? We have no idea about it. So that's why we call them law. And laws are universal. Universal means they used to be valid throughout the universe. It's not about these are the laws which are valid here on Earth only. Outside Earth, outside our solar system, outside this galaxy, and whatever, wherever you can go, the law should be valid everywhere. Whereas the theorem might have some specifications, might have some, you can say, proper conditions in which they are going to act. We will talk about them also. But let us move ahead. All right, before that, there is one question. So just think about it and tell me, if a charged rod is attracting a body, then charge on that body is what? Very basic question. You can answer it. Tell me. Are you there?
Yes, yes.
Tell me then.
Okay. Opposite.
Yeah. Just be attentive and try to answer as soon as you can.
Okay.
Again, another question. So again, this is just a theoretical question. You just have to think conceptually and try to answer it. So there are five balls numbered 1 to 5 are suspended using separate threads. Pair 1 2, 2 4, 4 1. This shows attraction. 2 3, 4 5. This shows repulsion. So we have to talk about ball 1. Think wisely and tell me. So if one is brought closer to the second ball, they used to attract each other. They used to attract each other means they must be of opposite nature. Similarly, 2 and 4 also attract each other. So 2 and 4 again must be of opposite nature. So from here I can say that 1 and 4 must be of same nature. Let's observe the next one. 4 and 1 also attract. So 4 and 1 if they are attracting again. So I can say 2 and 1 must be of same nature. So again 2 and 3 they shows repulsion. So if any charge is showing repulsion it means they are of same nature. So I can say 2 and 3 they must be of same nature. So if 2 and 3 are of same nature and 2 is same as that of 1. So 1, 2, 3 they all are of same nature. This is what we got from this. Then 4 and 5 are of same nature. So if 4 and 5 are of same nature, so I can say that 4 and 5 are of same nature as well as 1 is going to be of same nature. Now this becomes very interesting. Think about it and tell me. One may be neutral, must be positively charged, must be negatively charged, or must be made up of metal. This is not an easy question. Just think wisely and tell me. Think upon the observations and then try to answer it. You can do it. Think. So if you observe all the aspects and you
Yeah.
just tell about that 1 and 2 are attracting, they must be opposite. 2 and 4 attracting again must be opposite. So 1 and 4 must be same. It's not the case always. Here, because ultimately we got that 1 and 4 are of same nature, but whereas 4 and 5 are repelling, they are again of same nature. So 1, 4, 5 are of same nature.
Yeah.
Similarly, 2 and 3 are repelling each other. That means they must be of same nature. 4 and 5 must be of same nature. So 2 and 3 again are of same nature. But again, here we just saw that 2 and 1 should also be of same nature. So ultimately, we got that 1 is something which is there in both the cases. But it cannot be true because 1 cannot have both type of charges, that is positive and negative, and behaving simultaneously like the both. So it must be possible that 1 is neutral in nature because that is the only possible way that this situation stands. So this particular question says it cannot, must, will never be there, must, will never be there, must, will never be there. So we can say it may be neutral because we can't say about this. You got to know about this thing in few minutes. So just focus.
Okay.
Now there is another thing. If charge is invariant means if there is a charge and it is moving with a constant velocity, then the mass will remain same. But if the charge is moving with, you can say very high velocity, or you can say it is approximately velocity is very huge, very high. So there is another relation which is given by Einstein which says if the velocity of any object is approachable to the speed of light, is approachable to speed of light, its mass varies. This is the very important observation he did somehow while giving theory of relativity. Its mass varies. So it all depends upon the speed, or you can say the velocity. If anything is moving with speed of light, its mass constantly increases. If anything is moving with some random speed, which is not huge in number, its mass remains constant. So if the speed is huge, we can say that the body must be acquiring some charge. So that is what it means. Although it doesn't have much link with the numericals or the problems we're going to do. But yeah, this is one such thing that you need to keep in mind. Let's move ahead. Another question. Just think about it and tell me what will happen to the specific charge if velocity is increased. Now, if this question means velocity is increased to huge value. So the velocity will increase to a huge value. I can say its mass will increase. Again, this is something which is given by Albert Einstein while he was talking about theory of relativity. And that is the case where the time dilation and all the other factors came. But we don't have to go into that. We just have to stick to the mass and charge. So ultimately, we can say if its mass is increasing, so its charge also increasing. That is what you need to keep in your mind. In very rare case, such type of question can be asked. Let's move. Now, let us talk about what is the actual difference between conductors and insulators. Conductors and insulators, as of now, as far as our knowledge is concerned, we just understand that conductors are those which actually conduct electricity, and insulators are those which do not conduct electricity. But what is the actual factor? This is something which a small kid can also tell. But at this particular level, how we can actually define the conductors and insulators? Now, this is an important thing you need to understand. Suppose this is a type of matter I have. I am not talking about whether it is metal or non-metal. I am just simply saying it is matter and it is solid. That's it. Now, the difference lies between conductors and insulators is the difference in their geometry. Those matter which possess free electrons. Now, this is a new term, maybe for you, or maybe you have heard it before as well. So, those matter which possess free electrons, they are capable of conducting whatever it is, conducting electricity, conducting heat, conducting energy. Everything is possible. Now, what these free electrons are? These free electrons are those electrons which are not bounded with the surface or bounded with the nucleus completely of the atom. And if they got sufficient thermal energy, they will escape. If they've got sufficient thermal energy, they will escape. And that escape will ultimately result in flow of current. So that is the reason we call that they are able to conduct electricity. But in case of insulators, there is no free electrons. Every electron is bound to the nucleus, and whatever amount of energy will just supply to the system, they are not going to get excited from the state, and they are not going to move. And if they are not going to move, there is no current, and there are no current, there is no conducting behavior. So that is the basic, you can say that is the actual aspect behind conductors and insulators that we need to understand. These free electrons thing. Again, keep this point in mind. Let's move. So there is another question: which body can store more charge? Now the question is pretty normal, but the answer might shock you because whenever we are talking about any type of conductor, one thing that you need to keep in mind that conductors always store charge on their surface. On surface. So whether it is hollow, whether it is solid, the surface area will be same. And if their surface area will be same, the ability to store charge will also be same. It doesn't matter whether they are solid or whether they are hollow. So again, it's an important point you need to keep in your mind. Now, what you have to do after every class is whatever we have discussed and whatever important points I have told you to just make a note of them. Make sure you note each and every point right after the every class once I share the notes with you. Because once you write all these things will stay with you. Otherwise, after 1, 2 day, you might forget them. But that should not be the case because conceptual questions, whatever type of questions can be asked to you, these things need to be remembered or these things need to be noted. Otherwise, you will forget them. Remember these things. Let's move ahead. Another thing here we have is charge density. Now, these are the terms that you will be looking in numericals or the problems you are getting from your school. So that is the reason we have to discuss each and every term before actually moving ahead into the concept. So what is charge density? So charge density is simply you can represent or understand by understanding this fact. So before actually understanding the charge density, let us talk about density. So as of now, whenever we are talking about density, we'll simply say density is nothing but mass per unit volume. So in case of charge density, it can be of three types depending upon the configuration of the conductor. So on the basis of configuration of conductor, charge densities can be of three types. Like for example, sometimes a conductor can be a straight line or such type of conductors are called linear conductors. So these linear conductors, charge density is sometimes we call linear charge density. So the linear charge density is given by lambda, and this lambda is equals to charge per unit length, dq by dl. Remember this point. Similarly, sometimes there must be a metal plate which is conducting in nature. This conductor has some area. So whenever current flows through this area, there must be some charge density, and that charge density is represented by surface charge density. And this surface charge density is represented by the symbol called sigma, which is nothing but charge per unit area, dq by dA. Last but not the least, you might have a conductor which has some volume. So if a current flows through this conductor, what you will observe? You will observe that it is passing through its volume. So this is something we call volume charge density. Volume charge density, I guess now you can simply understand the relation. That is nothing but dq by dV. That is rate of charge per unit volume. Now sometimes different type of charge density is given in the question, and we might not be able to understand that what exactly is given to us. Linear, whether it is linear charge density, surface charge density, or volume charge density. So what we are going to do is we are going to identify their number. We are going to identify the each by understanding their units. So lambda or linear charge density has a unit coulombs per meter, whereas surface charge density has a unit coulombs per meter square, whereas volume charge density has a unit coulombs per meter cube. So by looking at the units, you can actually understand which charge density is given, and it is going to let us understand which type of conductor we have, whether a conductor have volume, whether a conductor have area, or whether a conductor has only length. So these are the charge densities that we need to actually understand. Does this make sense? Arnav, are you there?
Yes, sir, I am here.
Are you doing something?
Oh,
Does this make sense?
yes.
Next thing we have to discuss about methods of charging. So methods of charging simply relies on the factors, or you can say you just understand it by the fact that what are the various ways through which we can actually charge a conductor. Or you can understand it this way. Suppose there is a body. This body is, I can say, electrically neutral. Now just think and answer this question. If I'm saying that this body is electrically neutral, is it means that the charge of the body is zero, or is it something else? Think about it and tell me. If a body is neutral, is it charge is zero or is it something else?
I think charge should be 0.
No. If a body is neutral, it doesn't mean its charge is zero. It means that the total positive charge must be equals to total negative charge. And as a result, when we're talking about the net charge, so total positive plus total negative will ultimately give us zero. So whenever we're talking about a body is neutral, it means its net charge is zero, whereas the total number of protons must be equals to total number of electrons. That is the reason why it is supposed to be neutral. So whenever we are talking about methods of charging, we are actually trying to make a neutral body, a charged body. So this neutral body can be made a charged body either positively or either negatively. So in order to make a body positively charged, it must lose electrons. And in order to make it a negatively charged, it must gain electrons. That is important. Why we are every time whenever we are talking about charging, we're talking about electrons because protons are inside the nucleus. It is impossible to get them out and make or disturb the charge of the body by actually moving protons. So we can only move electrons. But if a body loses electrons, it becomes positively charged. Whereas if the body gains electrons, it becomes negatively charged. So that is what we have to understand here. So method of charging simply relies on that how we can actually let a conductor lose or gain electrons. So there are so many factors through which we can do this. The first factor is by rubbing and by friction. So generally what happens is when we rub some object, some I can say elementary or you can say some metallic rod with something which might have charge, like I can assume a silk cloth. That is a very prominent example because this is the very basic one. So what happens is this silk cloth will lose charge and this rod will gain some charge because of which this will become negatively charged as it has gain electrons whereas it has lose electrons. So if the rod will gain electron, it will become negatively charged. So it will acquire some negative charge, whereas this plate or this silk cloth will acquire some positive charge. So this is the very basic and very elementary method of charging a conductor. And this process is only take place whenever we are dealing with conductors. Conductors means those elements which has free electrons in it. If we are doing the same with if we are doing the same with insulators, the process will not take place. The reason you already understand free electrons. Now this is this triboelectric series, which actually let us understand that which object will actually or which type of matter will actually increase or gain or lose electron. So air is positive in nature, so it generally loses electrons, whereas gelatin gains electrons. Teflon also gain electrons. So this is something just here for your reference. You might see them maybe somewhere, but not in any case, I guess. So just think about it and tell me which body A and body B, will acquire a positive charge if their respective work functions are 3 electron volts and 5 electron volts. So this question has so many different terms. We'll discuss this question in upcoming classes. As of now, I am just skipping this because there are so many things that we need to understand before actually talking about this question. The most important thing is work function. So in upcoming classes, we are going to talk about this particular question. Although you can just think about it, and you have whole week next time. So next week when we're doing classes, and I might ask you about this. As of now, let us just skip this part. Now you can answer this question. When a silk glass rod is rubbed with silk, what will happen to it?
It will give electrons to the rod. It will gain electrons from the rod. I think so.
Yeah, this is what we just saw in the previous slide. So when glass rod is rubbed with silk cloth, so it will actually give electron to the silk cloth. So it becomes positively charged, and the cloth will become negatively charged. All right, this is something we need to define again, like here. So it's better to mark this whole thing as silk. Let us mark this as silk cloth, and it has glass rod. Now this is important. We need to keep this in mind. Glass rod will lose electron, whereas silk cloth will gain electron. That is important. So here the answer is going to be this, that it will give some electrons to the silk cloth, and becomes positively charged. Whenever anything loses charge, it becomes positively charged. Or you must have heard about cathode and anode, and that is the same thing we are talking about here. Similarly, cation and anion in chemistry also. So that is the same reason behind this particular problem as well. So next process of actually charging a neutral body, or making a neutral body a charged one, that is by conduction. Now what is conduction? So conduction is basically a physical process. So in this process, what happens is, when we just brought a charged body in contact with another uncharged body, like for example, suppose there is a sphere A, it is positively charged, and this is a sphere B, it is neutral. So I can say this was positively charged, and it has some positive charge on its surface, whereas this is neutral. So what happens here is, when this positively charged sphere is brought near the surface of this neutral sphere B, what happens here is, just observe properly. This is Q. I can assume that it has some charge Q. So what happens here is, if this A is brought in contact with B, charge has a very basic tendency. It flows. You just want the surface, it will flow. So what happens here is, this positive charge will equally spread across both the surfaces. And if we split them, later on, what we will find here is that A and B, they both are become positively charged. A was already a positively charged sphere, but here B will also become positively charged. By how much charge? If it was Q initially and it was neutral, so later on it will be half. So half of the charge will be distributed in both the spheres. The first sphere will also get half charge, and second sphere will also get the half charge. And this is the process called conduction. I'm not going into the definition part, but again, you just need to understand the concept, that what exactly conduction is. Conduction is a physical process. It requires physical contact. If there is a physical contact, then only conduction will take place. So that is the reason when we actually feel shock. So it's not like that we just got shocked because of the current and all. It's because of the property of the conductor, that is conduction. And human body is a conduction. It follows conduction. It is a conductor in nature. Human body is a conductor in nature because a body has so many ions in it. So whenever current passes through a body, or you can say whenever current finds a body, it considered as a conductor and just passes through it. So that is another important case, or you can say method of charge transfer. So now you can answer this question. This is very simple now. So question is find the charge on the both bodies after they are touched. Initially it has Q charge, it has zero charge. So if we just touch them and just put them apart, what will happen? What will happen finally?
Uh, Charge will get transferred, I think.
It will get transferred, but it will equally distribute. So whatever
Okay.
this charge initially the body A possess and B body has no charge. So what will happen finally? This body will distribute its charge equally over the surface of B as well. And later on, when we remove those two bodies or just put them apart, the charge will be distributed equally among A as well as among B. So that is what you need to keep in your mind. All right.
Yeah.
Now just think and tell me. You just need to understand it this way that in this case, this is a specific case. If the initial charge is R Q for the radius R, and we just brought it in contact with another sphere of twice the radius as compared to the first one, having initially no charge. So after when they're brought in contact or when they're touched, actually what happens is charge will again distribute equally, irrespective of their radius. It doesn't matter whatever their radius is R, it is going to distribute equally. So here again I can say the charge on the first body is going to be Q by 2. Similarly, charge on the second body is again going to be Q by 2. It is not going to get affected by the radius of the surface or radius of the body because this is what the property is. This is what the conductors are. It doesn't matter what their surfaces are. What matters is that their radius doesn't depend upon it. The charge distribution doesn't depend upon the radius. It depends upon the body which is brought in contact and whatever amount of charge it is carrying initially. It is going to get initially equally distributed. That is again you need to keep in mind. Next method of charging is called induction. Now, what is induction? So, induction is again a physical process, but in this process, we actually don't brought an object physically close to each other, or we do not touch the objects physically with each other. Let me just give you an example. Suppose there is a positively charged rod. It has positive charge all over its surface. Now, what happens is I just bought this rod close to a neutral body. I already explained you what this neutral means. Neutral means number of electrons must be equals to number of protons. That's why the net charge becomes zero. So if this positively charged rod is brought with the neutral rod or brought in contact with the neutral rod, what happens here is this rod will try to repel the positive charge that are present in the neutral rod away from this particular part. So what will happen here is when it is brought close to it, I'm not talking about charging, I'm not talking about actually touching each other, just brought close to it. So what will happen, this positive will repel positive charge. So the positive charge that might lie inside this neutral object will went away onto the opposite side, whereas negative charge, which actually attracts positive, will came close to it. So how, now what happens here is we just did what? We just separated the two charges. Initially, we can say these two charges are randomly placed wherever they want. There is no one to give them any kind of repulsion or attraction. They are just separated or they are just spread uniformly. And as they were separated uniformly, the net charge becomes zero. And that's what makes them neutral. But later on, what happens is when we just brought a positively charged rod, the positive will start feeling repulsion. Because of this, they just spread onto the opposite direction, opposite side, whereas negative charge feel attraction and they'll come close to the of rod side charge, we can say. Now the induction means, again, here we are talking about how can we make a neutral body a charged one. So in induction, what we have to do is we just earth this particular side. And what we actually do in earthing, we just connect a conducting wire and just connect it to the earth. Now what happens is, as this positive is pushing these positive charges, so all the positive charges which is there inside the conductor, which is there inside the rod, will start moving towards the earth like that. And ultimately, we'll have a negatively charged conductor. And this is the process of induction through which we actually make a neutral body a negatively charged one. Similarly, if you want to make a neutral body positively charged, you will do the reverse process. You'll brought a negatively charged rod. Earth, the opposite side, again, negative charge will flow into the earth and the whole body will become positively charged. And that is something we called process of induction. So as of now, we talked about three particular processes. First is charging by friction, second is conduction, third is induction. Remember the names and remember the difference between all the three processes.